So here are a couple of real examples of machine learning in action. So first, let's talk about Netflix. So here are some users on the left column. They're using Netflix. They're watching things. It says Chelsea loves romantic comedies, The Office, Friends. Recently watched Bridgerton, To All the Boys, whatever that is. Then we have Anisha, loves action, Marvel movies, sci-fi. Brian, it says loves rom-coms, drama series, etc. Right? So we have these folks here. We're tracking what they're watching, how much of it, what times of the day they're watching it, and things like that. And then we apply this machine learning clustering algorithm. And what it does is it's going to create clusters of these people based on their patterns, what they're watching, what they loved. And it creates, so these three, it saw the commonalities among some of the titles they had recently watched or loved. And it grouped them together. And then it saw that these three kind of fall into this action and thriller are their commonalities. So it clustered them together. And now we have someone who's fairly a new user on Netflix, and she's watched The Notebook and Friends. That's all the data we have on her so far. But the algorithm is seeing commonalities that really map more with this cluster. And so it's going to start recommending these titles based on what the people in this cluster were watching and seemingly enjoying. And this is, at least when I used Netflix, I was bumming off my sisters. Now, they cracked down on the accounts, so I haven't been on Netflix in a while. But when I was using Netflix, it seemed to pretty accurately give me recommendations that I would start watching and be like, I do like this. This is my taste. And sometimes they were surprising. Sometimes it was like, ooh, that seems a little like a little bit dark for me. I don't know if I want to watch that. And then really get into it. So I think one example that maybe is less good is Spotify. I don't know. I think maybe the motive to also promote popular songs kind of corrupts Spotify's ability to really do as effective as a job, but they're doing the same thing. They're doing similar stuff to Netflix with that clustering. And then machine learning, this would be where we actually basically create a predefined set of data where we feed it labeled data. So we say, this is spam, this is legit, this is spam, this is legit. And maybe we send it 1,000 copies of spam emails, 1,000 copies of legit. And then what we're doing is it's like when we're training this thing, it's like that analogy of doing a few practice problems, then looking at the back of the book to see if we got the answer right, and then doing a few more and keep on repeating until we have good exposure, so that most of the time when we predict that this is spam and check the back of the book, we're right. That's all we're trying to do with this. So it's really to demystify this. It's like, oh, this isn't really that complicated, the core concept. The training could get a little bit complicated for sure, but the core idea is pretty simple. And so the training process is, first we do feature extraction. So we're extracting the relevant parts of this email, right? And then we're assigning weights to these. So look at this, urgent language. That's a feature of spam. Excessive punctuation, right? How many emails have you seen, spam emails or phishing emails, that have this urgent language and poor grammar and weird, just all this weirdness, right? They're trying to get you to get prizes. Maybe they have weird sender addresses. The greetings are often generic, don't quite make sense. Call to action phrases, So these are kind of the things that stand out about these. And then it does a weight assignment. So it's assigning how much each of these should factor in to, its determination of whether this is a spam or not. And so what we get as the result is we recognize these patterns. We're able to just tell this is probably legit, this is probably spam. And look at this. 9 times out of 10, or 8.5 times out of 10, well, that's not what that means. It means this particular email is 85% confident that it's got the right result. So these things are never going to be 100% accurate. There's always going to be some room for variability. And this is why companies, when they send you that verification email, they say, if you don't see it, check your spam folder. Because even though Gmail or Outlook or whoever most of the time gets it right, sometimes they don't. But we're really just trying to get it right most of the time so that you don't have to sift through 100 useless emails to find the ones that are important. So let's talk about some common pitfalls of machine learning. And then I'm actually going to walk through, we're going to do some of it live. Number one is what we call overfitting. So this is when you memorize specific practice problems, but you don't really understand the concepts behind them. So my example is when I took my astronomy class here at ETSU with Dr. Smith, who is great, then I created a tool that took her text files, her long files on her website of multiple choice practice problems that we used for all the quizzes. She might have 100 problems, and feasibly, it would take some time to practice a problem, then scroll all the way down to the bottom and check your answer. So feasibly, you might get through 20 or so if you only had a few hours to study. So I created a program that converted it into a multiple choice kind of game where you would get instant feedback of whether you got the right or wrong answer. So then you could drill the problems, work through more of them quickly, and you could pretty much kind of memorize the answers if you wanted to. Now, this had a deleterious effect on our class. What happened was, after the class average moved up by about a letter grade, then I think she probably caught on, and she changed her quizzes to no longer be exact question sets and answer sets that were taken as a pool from the study guides, but question and answers that were about the same topics, but that didn't match the exact questions and answers on the guides. I was fine. I still could apply the core concepts behind them. So if I see a formula about I don't know, Newton's law, and it's a different problem, I still know Newton's law, so I can solve that. But if I just memorize the answers without understanding the core concepts, probably not good. And then the class average, the curve started moving back down, and I was like, this is my fault. So anyway, but this happens with machine learning as well, because we give it too much data that then it can't generalize, meaning suddenly I give you an email that wasn't the exact email that was in your training set, and you just don't know how to group it anymore because you didn't learn the core patterns. You learned to recognize exactly what you saw. And then the other thing is bias, and this happens a lot, and it's hard to curtail, but there are ways that we can check for it and revise our training and our data inputs to kind of correct this. And so this would be like you're only studying materials that are from a certain perspective, right? So think about if you're in a poli-sci class, but you have like, I don't know, this very leftist leaning history book or something. Well, that might not give you everything you need for your exam. It might leave out some important perspectives. Well, same thing will happen in training data. And I mean, this could create discriminatory outcomes. It could cause you to not get approved for a loan that you need to start your business, or not get approved for a loan for a house, or any number of things.